All right, folks, so here we go with 21 to 25. So question 21, here we go again with the paper shuffle. We're looking at the question starting with find cosine 2 theta. They do give you a triangle. So this is 21. The question is find cosine 2 theta. And they're giving us a triangle, another Pythagorean triple, which is given theta is there. So we have 7, 24, 25 as a value. So what I want you to first consider is, well, if I'm using cosine 2 theta, I have several choices, but I think I'm going to go with cosine 2 theta is equal to 2 cosine squared theta minus 1. And so in this case, the cosine of theta is 7 over 25. So cosine just theta is equal to 7 over 25. And if I apply this particular formula, this will be 2 parentheses 7 over 25 squared minus 1. And doing a little mental math, this is 2 times 49. I believe it's over 625, which if you do the math, let's see here. So we're going to go with, where's my calculator? You would think I have it out. I was recording 5 minutes ago. Oh, here we go. All right, so we're doing 1 minus this. I think I wrote it backwards. No, I did not write it backwards. So yeah, so it's 2 cosine theta minus 1. So in this case, a little math, you could use your calculator. We should get, let's see. I'm going to go with 2 parentheses 7 divided by 25 close parentheses squared minus 1. And I get a negative value. So I get negative. And if I go to, let's see, delete that, I should get negative 527 divided by 625. And so that's the gist of that question. This answer choice should have been answer choice A. All right, number 22, similar to that. On number 22, they're saying find sine 2 theta. And so they're giving you a triangle again, another Pythagorean triple, where this is the 90-degree, theta is sitting in here. This is 8. This is 15. The hypotenuse is 17. So sine 2 theta, if I'm looking for sine 2 theta, I'm going to go with, this is equal to 2 sine theta cosine theta. And if I sound medicated while I'm talking to you through this, I want you to understand, I'm just trying to be considerate of your understanding and letting you let this marinate as we talk. So sine theta for us will be 8 over 17. Cosine theta for us will be 15 over 17. So using the identity, this is 2 parentheses 8 over 17 times 15 over 17, which doing the math, what do we get? Do the math, enjoy the math. because it's math. So we get, it looks like a numerator of 240, a denominator, which I know just out of practice is 289. And I believe that should be answer choice and B as in boy. Fairly easy question, right? Here comes 23. I'm so happy the dog is not barking because it is raining. God forbid, rain, 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 go away. So Dolly doesn't bark at me all day. Okay, the last one, I believe they're giving us a tan to theta. So we're going to find tan of 2 theta. And tan of 2 theta that is equal to 2 tan theta divided by 1 minus tan squared theta. Okay. They are giving us a triangle. My suggestion when you start reviewing for this test, do the questions you do understand really clearly and mark them and put them aside somewhere. And then come back, skim the test or the review for the test again and see what next batch of questions come to your mind. Sometimes if you start with the easy stuff, it'll help you as you develop your thought process. So this becomes the tan of theta will be OA, so 21 over 20. And the top part of this is 2 times that. So 2 times all of that divided by 1 minus 21 over 20 squared. So doing a little mental math here, I'm actually not going to even bother. I'm just going to use a calculator, honestly. So this is 42 over 20 over, and then 1 minus 21 squared over 20 squared, which was 1.1025. Which gives us a value of, I'm getting a strange answer. I'm getting 1.1025. So what is this reduced to? Looks like if I do 21 divided by 20, so taking it step by step, this is, the top part is 1.05. And I'm dividing this by 1 minus 1.025, which gives me 0.025. So let's see what this breaks down to. There's many ways you can approach this. I'm just taking the precautionary way, which most of you will. So in this one, it looks like our answer choice should be A. It should be 840. Negative 840 over 41. So 840 divided by 41 comes to 20.48, which is what I got on a calculator initially. So I'm comfortable with that. Let's go with answer choice A. And do remember this is 2 over 1. That's why it's 42 over 20. And this is 1 minus. If I open this up and actually do this the longer way, because I went decimal wise, which was not wise, I don't think. So let's do it the long way. Let's do 21 divided by 20, and let's square that. So parentheses 21 divided by 20 squared. I'm still getting that 1.025. Let me go back here. I'm still getting 1.1025. So I don't know what to do with that. If you want to suck it up and just do 21 times 21, you're going to get 1 minus 441. So let's go with 441 over 400. And that's the square of it. So you're going to do 1 minus that, and this 1 becomes 400. So you have 400 over 400. So you end up with 42 over 20. 400 minus 441 is negative 41 over 400. So keep, change, flip, have a happy time doing that, and you're going to get a 40 over 41. All right, number 24. All right, 24, they're starting us with a simple question. They're saying we have sine theta that's equal to 21 over 29, and it's in quadrant 1, so it's positive. They want us to find cosine 2 theta. So I want you to think about this one in terms of when you do the math, just remember the identity for cosine of 2 theta, that is also 1 minus 2 sine squared theta. So I'm going to go with 1 minus 2 times 21 over 29 squared. And when you're done with the math, it may take you a minute, you're going to end up with negative 41 over 841. So that's number 24. Number 25, we have cosine theta is equal to 7 over 25. It is in quadrant 4, so it is positive. I'm not going to bother. They want us to find. And so if I'm finding sine 2 theta, I need to remember my double angle formulas. So sine of 2 theta is equal to 2 sine theta cosine theta. So here's what we do know. We do know that the sine, so we have the cosine, the sine of this would be 24 over 25. So sine theta is equal to 24 over 25. If you don't know how I'm jumping to that conclusion, draw a triangle. Here's 90 degrees, here's theta. According to this is 25, this is 7. Use Pythagorean theorem, you end up with 24 here once you solve for that. So the sine of theta would be the opposite over hypotenuse. And that's how I'm getting 24 over 25. So the solution would be 2 parentheses 24 over 25 times 7 over 25. So we know our denominator should at least be 625 is what I'm thinking. So I know that this is going to be 2 times 24 times 7. So 2 times 24 times 7, that gives us 336 for the top. And I know the bottom has to be 625. So that means that answer choice for the 25 should be D. Okay, let's take a look at 26. I know I said I'd stop at 25, but let me go ahead and keep going because my dog is not barking and I am ecstatic about that. So here's 26. On 26, we're given complete the identity as the question, and they're giving us sine x plus cosine x squared equals what? And so in this question, I would also ask you to consider that if I go ahead and I just simply FOIL this, that I'm going to get sine squared x plus sine x cosine x plus cosine squared x. Here's a huge hint. Does this look familiar? I hope so. So that's going to give us 1. Okay, just don't do that. Okay, so 1, see if we have the black one. 1 plus sine x cosine x. Okay, obviously you know why I did this, right? Pythagorean identity, sine squared plus cosine squared is 1, hence this is 1. Okay, so I'm getting 1 plus cosine, I'm sorry, 1 plus sine 2x in this case. Did I lose something? No, is there a 2 here? This is factored. Give me 1 second, let's verify that. Because, you know, the teacher never makes a mistake, ever. No one ever heard or said that ever. Okay, so this is sine x plus cosine x. All right, so inner, outer. So no, this is 2. There's a 2 in here. Okay, so I have 1 plus 2 sine x, which is the equivalent for me if I work this backwards. So look at what I'm saying. We have an identity that says, what if I use, okay, have it a moment. So I get 1 minus. Why do I have 1 minus? There's something wrong here. I'm having a moment. So if this is 1 plus 2 sine x cosine x. Where's the identity? Give me 1 second. I'm really having a moment here. Let's see what this is. Hold on. Okay, so brain fart averted. Here we go. This part of the formula right here is actually going to be 1 plus sine 2x, and that's using the double identity angle. I actually forgot that. So 27. Power reducing for this one. So you have to refer back to your power reducing identities. So in number 27, they're giving us 8 cosine squared x. And so we're going to re-express this as 8 parentheses 1 plus cosine 2x over 2. If I distribute the 8, notice that this is going to become 8 plus 8 cosine of this angle 2, or angle 2x over 2, which if I divide this and this by 2, I'm going to end up with 4 plus 4 cosine 2x. And so that's number 27. That answer choice, I believe, is A for your review packet. Okay. 28 is another power reducing. I think you could do that one yourself. I'm gonna leave it to you. This is number 28. 29 I am gonna do because I want to refresh your memory on 29, because they give you in this one sine to the power of 4x. And so we're gonna split this guy up. And so we're gonna call it sine squared x squared. And if you recall, when we do this, this is basically 1 minus cosine of 2x over 2, and that is squared. So that is what this represents here. When you FOIL this, you're going to get 1 minus 2 cosine of that angle 2x plus cosine squared of the angle 2x. And all of this is over 4, because we're basically foiling here at the top and we're squaring the bottom. That's how we get that number. Okay, if I divide all 4 of these values, look at where I'm underlining. Technically there's a 1 here. I'm going to end up with 1/4 minus 2 over 4, or 1/2 cosine 2x plus 1/4 cosine squared 2x. Let me see here. I also want to reduce this. This is still a power of 2, but remember we're using power reducing. So I'm going to re-express this with 1/4 minus 1/2 cosine of 2x plus 1/4. Let me do it this way. 1/4, and I'm going to do parentheses. Remember, we're replacing this to reduce the power, which is 1 plus cosine of 2x over 2 again. All right. A long question. Make sure I'm on the right page here. So I did 1/4 minus 1/2 cosine. Okay, so we're here. I just did the second part. Okay, so now I'm here. So I have 1/4 minus 1/2 cosine of 2x. And keep in mind, I'm multiplying across here. So plus 1/8, if I distribute 1/8, plus 1/8 again, cosine. In this case, this will become 4x. I also forgot to put the 2 here. So this is a 2 here. All right, so if you use the identity, you would not have missed that. If you weren't just following me, you probably would have waited for me to correct that. So one more time, I'll put it in red. This should have been placed here. Okay, and that's how we get this 4x here. All right. The second to last line continues, where I'm going to basically add like terms. So I'm going to take the 1/8 and the 1/4, add them together, where I get 3/8. So that's this piece and this piece together. Going back to the black ink. Minus 1/2 cosine 2x plus the 1/8 cosine 4x. And finally, I arrive at the answer. So I'll have 3/8 minus 1/2 cosine of 2x plus the 1/8 cosine of 4x, and I'm done. Okay, so Merry Christmas on that one. That was a doozy. Okay. Let's take a look at number 30. Oh, that answer choice, by the way, would have been answer choice D for number 29. Okay, and I'm going to stop at 30, I promise. This is a lot of notes. So we have cosine of 2x, and that's equal to square root of 2 over 2. And so by default, so in this case, you end up with x equal to, let's see here. So x is equal to pi over 8 plus n pi. And obviously the only answer choice that has pi over 8, you could stop there. Just remember, you start with n equals 0, n equals 1, and so on. And you should get those values that we see there. All right. Let me stop the video here, and I'll resume the next 10 on another video.